It's working. Yellow, yellow. Okay. Audio is working. Beautiful. And let's open this. Let's see so I can control this. It's right. It's that portion. All right. All right. Yeah, all right. Let's get started first day. First off, this is my man Joel. So I haven't from the spring break, so just introductions. But and all right. So we were going to be talking about polynomials. So we kind of did the week before spring break. We did quadratic functions, and so this week we're going to talk about what are called polynomials. But to give us, so we needed to do a couple things to get some patterns for what polynomials are. So I want to start off with a couple graphs that we do know and a couple graphs that. Okay. The way I want to do this actually, so doing four graphs is going to take a while, so I want to split this up. And have half of y'all do x squared next to the fourth, and then I'll have the other half do x cubed next to the fifth. Look at the results. And the big thing out of this is, and you'll probably see it pretty immediately, there's a pattern. What's going on here in graphs. So what I'll do is I'll have first row, then everybody out here. Let me have you guys do x cubed and x to the fifth, actually. And then the second row, or the back two rows, I'm gonna have you all do x squared and x. So just the normal straight graphing that you guys know. So I'll give you guys a little time to put those graphs together, and then we'll go over what you're getting. You were good. Yeah. For your internet expert, yes.
Right. Look, graph.
The graph.
Not a sketch.
Yeah, not such. I'm looking at the next few.
We got those two on. So there's two. We had to learn to live. We'll be fine.
Yes.
You know what?
That's what's your.
You got something?
And that's, and I think that's, so.
Oh.
It's fine. I told you that, that's. And it's, like, the contribution.
Then
There's no one.
This is a negative.
All you do is.
Spring break was last year.
Yeah, it is always started.
16 we get. No, we had 16-year-olds. Oh. There's EDP though.
Yes.
I get the person.
What's wrong?
Yeah.
I did.
She said that,
But I mean, let's.
she got her doing. Honestly.
Just can't. I was doing. I mean, for the 66 was really selling off. Like,
You know it.
yeah,
He said it down.
I didn't know, I said it was. Yeah, doesn't crack this shit. Crack it then. The one I admit. No, no.
I sprung it. Bro, I'm so mad. I got 16.
Good. So what's y'all's hesitation on graphing it?
The only thing that was like That it was not really confusing, but I had to pay attention because this one's a cube is three.
Yeah.
Like if it's a negative, negative times negative, it's positive, but then you get the negative.
Yeah, you got it, yeah.
Times do the next one. Well, volunteer you. Yes. Like that. Oh, yeah. Mm. Mm. Oh, that's too good. This guy is so smart. You're so smart. Oh, you. That what? That. Imagine. Awesome. Oh. And get no. Nothing. That's one. That's one. What are you doing? One thing. 32. Yeah, I'm not sure. Pretty soon.
I think that's only the second or third time in my life that I've said your frames are awesome. Just, oh.
Oh, this shit. All right. That works for Siege. Reminder. No, I just get 32. Item 0 1. Well, cool. Are you gonna send some? Well, give me 30. It's like, this is always news. Like, seriously. So, who's that?
Yeah, I think.
Maybe it's just, it's, oh, okay. We're just gonna sketch it.
So every single start grabbing into the things.
Alright. I want to go restroom real quick. You know, all dude that goes like, do you have one?
Yes.
You know what I'm talking about? You know what I'm talking about? The bald dude is like, they go up to, or you know what I'm talking about? He's like a bald dude, some kind of counter, and he's like, excuse me, can I get over here? You know what I'm talking about? It's which is old light skinned dude.
It's very interesting.
You never seen that video? No, brain run. I'm cooked right now. I'm not sure. I'm not too.
Yeah, that's fine. Yeah. Well, it's actually easier to. The
For a second.
I think it's.
Yeah, it's the same graph, it's just longer.
Sure, but the negative two premise.
Hey. You can You can also see. You know, code hours. That's that.
Negatives, 5, 3, 6. Oh, good stuff. All right, let's see, then, not everybody's finished, but let's see what you guys are getting. Sure, finishing. So let's start out with what y'all got on the back two rows, the x squared and x fourth. At this point, you should be very bored with the x squared graph. Literally, we basically like done it for 2 weeks total out of the course. So what x's did y'all pick? What y values did y'all get? For us?
You said for vector?
Say it again.
You said for us?
Well, yeah, because I gave the back two rows. I think I gave you all the x squared and the x fourth graph.
Yeah, for the values, I chose -2 through +2,
Yeah.
and it was 4, 1, 0, 1, 4.
4, 1, 0, 1. Any trouble with those calculations though? So let's graph that. -2, +4, -1, 0, 1. There is our the old parabola that we're used to. Then the fun parts. So for x to the fourth. What x values do y'all pick? Yeah, so -2, +2. And then what'd you get for the y values? Yes. 1, there's 0, 1, and 60. Perfect. So this one, when we graph it. So it's good, actually. We kind of clarify where these graphs are sketches. I will say that you get to graphing stuff like 16. So one way to do this is you try to actually make the marks out so you get the 16. I don't know, are you guys familiar with like a photocopier or just the idea of like making images smaller or larger, kind of sizing them and, sizing them down, sizing them out? So the one problem with trying to make marks out to 16 for this, like maybe we count by 2s or 4s or something like that, is that when you size things in, everything starts to look like a straight line, or this curves start to look like straight lines, so you lose some of the detail that you would have otherwise. So what we're gonna do here is we're not even gonna size it out. We're gonna take sort of, when we graph stuff like 16, I'm just gonna put a mark way high or way low. And so that makes it officially a sketch, but what it does is it communicates to the reader, yeah, like this number is kind of out of range, but you get the idea. You get the idea that it's really, or that it's really low. So I'll do roughly that. So -2 gives us 16, which is way up here. And then -1, 1, 0, 0, 2, 16. So what shape did you draw through it? Yeah. So it's still a U. but it's just a much more elongated. We'll go back then and maybe talk about some patterns there, but let's get to the x cubed and x to the fifth. So that's the first row. Can somebody give me for x cubed? What were your x values and what did you get for the y's?
Negative 2 to 2.
Yeah, we'll still do negative 2, 2, negative 2, negative 1, 0, 2.
For negative 2, I got negative 8.
Good.
And then negative 1. And then 0. And then 1, 8. But you think it. Nothing. There.
So we get the now familiar squiggle. Again, the climb parts, so what about x to the fifth? So you pick the same numbers, negative 2, negative 1, 0, 1, 2. And what'd you get for the y?
1.
So negative 32, negative 1, 0, 1, 32. So you're multiplying some number 5 times, you notice it gets high really quick. Yeah, like. So that was one thing I was mentioning last class, as we start to do, not just, we'll talk about these called power functions, but especially we get polynomials. Once you start having these functions with a lot of powers and larger powers, numbers just get big really quick, and so we're actually gonna have to sort of like just be easy and get used to the fact that like we're no longer gonna be sitting around a lot of small numbers. We're gonna get big numbers, and that doesn't mean you did something wrong. That's actually what we should get. So then when I go to graph this, especially here, and the best I can do with 32 and negative 32 is to be like way up here, way down there. So let's do that. So negative 2 way down here. Negative 1, 1, 0, 0, 1, 1, and then 2. Wait. And so what does this graph look like? What did you draw through?
It goes straight here.
So notice it's still the same shape, it's just stretched out. It's like if you take a rubber band and stretch it out, it's same overall shape. So yes. And so with all of this, or kind of seeing all of this, then the first thing I want to talk about with graph or is the shape of the graphs. So looking at all of them, what do y'all see? What's the pattern?
Up there for the values of the x's, like when you go negative, it's the same value.
Okay,
But like for negative 2, negative 8, and for the 2, negative 2, 32.
gotcha. So are you talking about on all the graphs
Oh,
or
right now, I was just looking at.
for those who know that? So he's looking at the 2 that he had with x cubed and x to the fifth, and yeah, it's you get very similar values. So it's either positive or negative. The negatives gives you negatives, the positives gives you positives. So what I'll have you guys do is, so just think like a minute or two at this, but I want you to look at all four graphs. Look at the powers, I want you to see if you can find a pattern to the shapes of the graph compared to the powers. So I'll give you guys a couple minutes, like don't say anything initially, but stare at it, see if you can find it.
Yeah, we can. I'm thinking. And, but it's. What do you get? Zero. I wasn't gonna say -1. Zero, zero. I can. That's not work.
What do you else? If you don't see anything, that's fine, but this is one of those things, if I tell you a pattern, this one's not so bad, but if I tell you a pattern, you're not gonna remember. You remember things by trying to figure it out yourself, whether you figure it out or not, just that action of trying to figure it out is actually what anchors it in your head. So what do you guys see?
Fish.
Yeah, so it looks like if they're even, if the power is even, the shape is a U. Yeah, so it's odd number, I think it's mentioned you get negatives on the negative side, so that's there. So that's what it looks like kind of from these four, and that's gonna continue out. So that is actually our pattern. And every, so we call these power functions because it's just x raised to a power, so nothing clever, mathematicians are boring. Except for we like fonts a lot. But like all that. Every even power function, every even power, so 6 power, 8 power, whatever, it's just gonna keep looking like a U just stretched out for it. And every odd power, third, fifth, seventh, ninth, whatever, it's still gonna look like an S, it's just gonna keep stretching. Still get that basic shape. So that's something then that you can expect. So like we're talking about when we were doing the graphic before, you start to expect, you sort of know what the shape is gonna look like before you start. That's absolute, you can absolutely expect that. So if it's even power, you're gonna get a U. If it's an odd power, you're gonna get an S. In this homework, they're gonna start asking you about something called an behavior of the graph. So the idea is basically, if you look at the graph and you blank out the middle, what's happening on the end of the graph? So for instance, on x squared behavior. So as I'm going left, as I kind of like look at the left end of the graph, what direction is the graph? Yeah, so as I'm going left, or as I'm looking left, in terms of up and down, which direction is it going? It's going up, yeah, that's actually, you need to know which direction I'm looking for. So as on the left end of the graph is going up. So I'm gonna write it this way, which is the way I want you guys to write it on the test. We'll talk a little later on today about the way that homework wants you to write it. But the way I'd want you to write this on a test, the way I want you to think about it and remember it, because this is the way that actually most folks do it and what it means. Anyways, but the left side of this graph is going up. What's happening on the right side of the graph? It's also going up. So then what about, what's the end behavior for the x to the fourth graph? Say it again.
Would be left, look right.
So if you look at the left end of this graph, it's also going up. The right end of this graph is also going. Left up, right up. Notice that they're the same. Which we talked about, the shapes of these are essentially the same, so the shapes are the same, then the behavior on the ends of the graph, or the overall pattern of the graph should be the same. So the end behavior should be left up, right up. For x cubed and x fifth, what would the end behavior there be?
Left down, right up.
So on the left, the graph is going down. So exactly, so left down. But then on the right side of the graph is going up. So right, that'll be the same for both. Again, this is a lot of this, I'm having you guys explore and figure out some things as kind of a setup for the work that you're gonna be doing. But speaking of the homework, this is actually, I think 3 out of the 8 problems on the homework are what is the end behavior? Yeah, it's all we're looking at. So, similar question.
Just like up and down.
It's just up and down, yeah, so it's basically asking on the left, so if you think about it, in some sense, it's using left and right as position. And the behavior is what's happening, yeah. Question. All right, so then, like I said, these are power functions. This week, we're gonna look at polynomials. Polynomials are when you combine power functions together. So we know what each of these functions looks like separately. Yeah, give me a second, I'm in with this camera. We know what each of these look like individually. Fun question is if I'll, so, let's try to graph the following. Let's do something. Good job. we want to look at what happens when we combine our functions together. Combine them together, we call them polynomials. The word polynomial, by the way, so the reason they call them polynomials. What does the prefix poly mean? Multiple, many. Nomial just means part or piece. So they're literally just saying a function made up of many pieces. These pieces are all power functions. So the x raised to a power, maybe with a coefficient, but just a bunch of those same. And you could have two of them, so we'll do more on Thursday that have more pieces, but start today with some polynomials with two pieces, all those binomials. If 3 pieces, we call it a trinomial. Then mathematicians got lazy, so if it has more than 3 pieces, we don't give it a special name, we just call it a polynomial. But it can have as many pieces. But that, like I said, so all polynomials is staple some power functions together. So I think the fun thing, the cool thing, the pattern I want you to think about is we're kind of graphing these and getting these going. And both today and Thursday is, so if these are what power functions look like, then when I staple them together, is my graph just some simple combination of those, or what happens to the graph? Does the graph, is it some simple combination, some smooth over of those, or is it radically different? Or what is that? So I want to get you guys to work through with these two graphs, but I think we'll do them one at a time. So I want to give you guys 5 minutes or so to get the graph of x cubed plus 2x going. Same exact thing you just did. So I want to start out the same graphing that you've done. On Thursday, I'll show you guys how to figure out some things about the graph before you get there. It'll help you build the table. But today I just want you to build the table like we've done on every other graph. So pick some x values, plug them in, get your y values, and see if you can get a graph. So give you a little bit of time on 5. She was in some screen. The one would have straightened. Yes. What is it? So literally it's the same printout that is in there, but just word as X. Calculations basically.
I gotta go. I gotta go. That's what. Work. I think we may need to.
What?
Sure.
It's fine.
No. Anybody? We have to listen.
They don't.
Oh, so on those,
That's trying to get this time embrace. That's not
the way we write on. Five. That's something. It's just not.
It's just bringing with that. Oh, wait.
That'll be, yeah, that's very possible. I can do. Should try. That.
Yeah, we're running with live. Wait, I want to.
Like.
One is how there's two and two five those. So
What's this error?
I'm running with somebody. No, I'm just playing race. I did try to hit these.
See, so I just want you to, because the thing is like, what I see you all doing is to see. So like what I'm seeing is you're typing this, but you're missing the plus. And then you're gonna be missing also the two, so that's what I'm saying. It's like,
For sure, I guess 6:30. The feeling blue.
That's
Oh, yes.
or for zero. Hmm. Well, yeah, so it's sometimes they are.
Going on? You look for money?
How
Oh, this is funny. You might have.
when you're doing it. Like,
Oh, I messed it up.
so she can record it about.
It's 3? Yeah, I was thinking about that. Okay, for negative one.
But. So if x is -1, that means that. Think about it like it's. At least three. That's. Okay. Yes. Alright, so somebody give me the x values you picked. Let's see. So -2, -1, 0, 2. And what y values? Sure, are you still looking? Okay, so -2 is a 0, and -1 does give you a 1. And then what'd you say? 0 though, but let's work on it, the 0 should be a 0, so if I plug in 0 here. We gotta do exponents first, so what's 0 cubed and 0 squared? 0. So I have 0 plus 2 times 0, but I gotta do that too. Sure. Yeah. So that's gonna be a 0, and then all of those. Question. One is 3, yes. Although 1 is 3, and then what about 2? 16. Yeah. All right. So these are correct numbers. So how many of y'all then, so first of all, how many of y'all looked at these numbers and said, this is weird, I don't know what's going on? So just how many of y'all tried to get the graph going, and once you saw the dots, said, this is weird, I don't know what's going on?
I was.
Okay, so a little more there. So I'm saying that because, so we'll get the graph going, but if you're feeling that way, that's actually really normal for polynomials. So the thing is, power functions honestly have a lot of symmetry, very simple, the numbers repeat. As soon as you combine two of these, the surprising thing is numbers, symmetry, all of it goes out of whack. That's just combining two of them, let alone 3 of them, 4 of them, etc. So it's actually kind of an interesting thing. I've been studying polynomials for like 600 years, and they just keep finding that you just put in a little bit of this stuff and you get a ton of complexity. All right, so we're gonna need a way up there, but otherwise, this is the way. That is me. So we have -2, 0. I have -1, 1, 0, 0. Then 1, 3, and then 2 is way up here. So what would y'all say the shape is? What did you draw through this? Okay, so kind of a good. So Savannah caught that. I mean, one thing that's happening with this is we kind of don't know what's happening after this point. We don't know if it goes back up or it goes back down. So in this case, it's actually helpful we kind of need to pick another. So we're gonna need more than 5 points. It's like not all the time, but sometimes. Just to make sure, like it's obvious the right side of the graph keeps going up. But again, here, I don't know if it sticks, if it keeps going down through the x-axis or if it bounces back. So the -3, when you plug it in, did anybody do that?
-9.
Say it again.
-9.
Yeah, that gives you a -9. So actually, well, down to 8, so you go down one more. So that'll be way down, that'll, not way down there, but that'll be down there, and so Savannah's exactly right. So this graph kind of keeps coming up, has like nice little gentle hill there, and then a really steep valley. And this would be my turn. I just combined an x cubed and a 2x squared to get that. Compared to our power functions though, so this polynomial is made from a cubed and a squared. Which one does it look more like? Say the cubed, what do you guys think? So it does seem to look more like the cubed, at least what we were just talking about. If you blink out the middle, the ends of the graph, the end behavior looks exactly like a cubed. And notice that what's the highest power between the two? the cube. So maybe when we do all these graphs, the end behavior is always gonna look like the highest power. That ends up being true. So no matter what polynomial I put together, I could have a polynomial of 5 pieces, 6 pieces, whatever. Whatever the highest power is, that's what your end behavior is gonna look like. And so the overall, your graph is roughly gonna look like that graph. So highest power tells you the ends. The middle is where the middle gets squirrely always. The middle doesn't look like that highest power. So we wanna write the end behavior on this graph. What I wanna show you guys though on this one is, so again, this is how I want you to write end behavior on a test. However, for this homework, they have you write end behavior a different way, so I just kind of want to show you how that works. The way they have you write end behavior on this is the way that you would do it in calculus class. So I don't know why they do this in a algebra class where y'all are not gonna go on to do calculus. But let me just kind of tell you how it works and see if it makes some sense of it. So the end behavior. So they're gonna give you this little statement. They're gonna say as x approaches or goes to negative infinity. And let's think about the x-axis. If you're going to negative infinity on the x-axis, which direction are you going? So all this is trying to say is as you go left. And as you go left, what happens to the y values? It goes down. So our graph goes down. So you're gonna say as you go left, as x approaches negative infinity, f of x, my y values, goes down, which is gonna be what? Negative infinity to negative.
Oh, okay.
Yeah.
It's just like it works.
It's literally these words, yes, it's literally these words turned into, honestly, the symbols that we know from like intervals. Okay, positive infinity, negative. Yeah, so it's not horribly complicated, but it looks pretty good. Good. Yeah, so, and this is just the left part, right? So then we also have to say, you gotta do the right. So as x goes to the right, as x goes to infinity, what's happening to the y values? They're going up, which means they're going to positive. So you'd say as x goes to infinity, f of x goes to positive. And like I said, this is literally just this homework. Or I guess we'll probably see it on the next homework too, but just, actually, no, they don't ask that about end behavior and split. So in this homework, this is how they're gonna like talk about end behavior. So do it for this homework, but literally on a weeks on tests, I want you to write it this way. I don't want you to write the appendix. Because y'all aren't gonna do that. It's a sentence, but it's, yeah, it's not an object. It's not necessarily quadrant against direction. You just got, you want to think of it around, right, so it's like, it's right. Right direction, that's what it is. Yeah, okay, yeah, it should go pretty well.
Good medicine for this. When you're actually there.
All right, so then let's play the same game for Chivex. I'll give you guys a little time to get that graph going and then also tell me the end behavior of that graph. Yeah, trying to, the pieces are actually. That. One. I was saying that basically water's power. So. See this shit.
What? That's negative two. Or minus two. I put so many good at the.
To play it. Is your team, well, I guess you didn't get to play it as much yesterday. Is your team still at 112?
This is a different game.
Oh, it's different again.
Here we go. Disable it. Oh, wait, says the wheel. Yeah. Maybe like likes of which is wheel place and the sun. Look up. And have a big point where when it is, it's kind of that. Wow, this is.
Good. So let's jump in on it and get the. So let's see, the X and Y values. What did y'all end up? What did y'all end up with those? Okay, so same one, good. And then what did you get for the Y values there?
0, 3, just.
-3, 0, good. That's right. And then once you guys got to the graph, did anybody choose any other values outside of that to kind of finish out the graph? Yeah. So, so this is good. This is what I saw is I think some people stuck here, but they still saw that overall this is a W, so you just kept drawing. But if you're gonna stick here, just make sure you can identify what's kind of happening on the end of the graph and then just keep drawing that direction. But yeah, really, we should pick a -3 and a 3. What did you get when you? Go for Y value term? Yeah. So -3 ends up being 45 and 3 ends up being 45. And that is not a fluke. Again, the numbers just get big very. So let's graph. So something. So -3 is way up here. No, -2 is a 0. -1 is a -3. 0, 0. -3. 2, 0, and then 3 is back to being way up. So everybody that I saw got the shape correct on this. So what is the shape on this? It's a W. All my best freehand W here, but exactly. Something roughly like this. Sweet. Again, which one of these power functions does the end behavior look like overall? Say it again. Yeah, quadratic. So it looks like an even power, which again our leading, perfect, yes. Our leading is fourth power, so that makes sense. So again, the ends of the graph look like a parabola. The middle is weird stuff, but the ends false. So on the end behavior here. So as x approaches -infinity, so we go left. How would you write the rest of that out?
Thanks.
Yeah. Yeah, goes to positive. Yeah. So that's basically left goes up. And then as x goes right. It also goes up. So f of x also goes to positive infinity. Yeah. It's all right. I think what we'll do is, so when we come back on Thursday, so This is the auto way of getting the graphs, but we'll kind of go back on these and some other functions, and we'll look at ways that you can figure out some details about this graph first, so we can build it, can actually build it, well, sort of quicker. But anyways, so we'll do all that on Thursday.
All big environment.
So can you erase the board again? Just check. Although there may not be spray in this room, so I have to do it the hard way. This also. It's a perfect. I totally not. Yeah, that's all, this one's 5 hour. And literally, so you actually on asking questions, sit here. Yeah, yeah, so that's the point. Cross check. Yeah. Just all right, sure, very violent. I was thinking, let's see. It might, yeah, it might just. If it wasn't, there was another student, that same thing. Usually when it's at students, it's actually Wi-Fi, like, it's just something. Everybody's in. Yeah, and that's what I mean was weird about investing. It wasn't working, that was more of a server, I'm saying, sure. Yeah, that's true, right?
Okay, I So I don't know.
Yeah.
And I was again, I was these are all those very functional to be.
Yeah.
So I know this is very based on that. But I know I did remember.
You're great.
Okay, you're all set. You remember me from every class, it's like,
Yes.
I'm asking you to go back in time, so. You just have to sign them.
Yeah, just after. And it's, yeah, I'm on my first time.
You're the one that's I thought you were the only one. Or, well, you know,
Yeah.
it just, they get it from like your culture,
Yeah.
it was matter of me. So,
Okay.
here I am, I see. This one, oh, you already did, okay, thank you, this will be like the end of this thing, okay, oh, so much.
Well. How's it going there? It was, I read. But I have.
Oh, no, oh, that.
It was good. Good. We played well. We didn't get on the vibe. But so. I know. On the. Yes.
Oh,
Alright, so that one's that thing, yeah, like when I had. It's hard, I know. Alright, let me finish it out. Alright, we're gonna walk to this restaurant, get some food. Food! Exactly. That was funny last night when we were walking down the street and you were like doing the Mario.
Mario. The mushroom, the mushroom.
Was that, yeah, was that a video? Did you show me that video? Or I think maybe I just saw it, but there's a video like that actually. It's hilarious.